Good morning everyone. Today we discuss different types of neurons, generation and conduction of nerve impulse. If a neuron has two or more than two dendrites and one axon, two or more than two dendrites and one axon known as multipolar neuron. Multipolar neurons present in cerebral cortex. Multipolar neurons present in the cerebral cortex. If a neuron has one dendrite and one axon, bipolar neuron. If a cyton has one dendrite and one axon, bipolar neuron. If a cyton has two or more than two dendrites and one axon, known as multipolar neuron. Bipolar neurons present in the retina. Unipolar neuron. If the cyton contain only axon, it is also axon end. If the cyton has only axon, means without dendrite, known as unipolar neurons. Unipolar neurons present in embryonic stage. So multipolar. If cyton has two or more dendrites and one axon, multipolar. Example, cerebral cortex. If a cyton has one dendrite and one axon, known as bipolar neuron. Example, retina. If a cyton has only axon, means without dendrite. Cyton without dendrite, known as unipolar neuron. We discuss myelinated and non-myelinated neurons. If neuron is covered by myelin sheath, they are known as myelinated neuron. In case of central nervous system, oligodendrocytes secrete myelin sheath around several axons. In peripheral nervous system, Schwann cells secrete myelin sheath around a particular part. For example, it is a particular part of axon. Schwann cell present around a particular part of axon in the form of several layers. Only outer layer is known as neural lemma. All the inner layers collectively known as myelin sheath. Outer layer is neural lemma. All the inner layers collectively known as myelin sheath. The narrow parts of axon known as node of Ranvier. The portion of axon between two nodes of Ranvier known as internode. So, one Schwann cell protect one internode. Number of Schwann cells equal to number of internodes. 1, 2, 3, 4, 5. In this diagram, 5 Schwann cells protect the axon. In peripheral nervous system, Schwann cell present around, so it is a particular part, present around a particular part of axon and protect that particular part only. And the Schwann cell is in the form of layers. For example, it is the part of the axon. We cut the axon in transfer section, part of the axon. Around the axon, the Schwann cell present in the form of layers. Outer layer is known as neural lemma. Inner layer is known as myelin sheath. So, in peripheral nervous system, Schwann cell protect a particular part of axon. In central nervous system, oligodendrocytes secrete myelin sheath around several axons. The narrow parts of axon, due to absence of myelin sheath and neural lemma, narrow parts are present in axon. The narrow parts of axon known as node of Ranvier. Leakage channels, voltage gate channels absent in the part of the axon encircled by Schwann cell. So leakage channels and voltage gate channels present in nodes of Ranvier only. So in myelinated neuron, information jumps from one node to another node. Information jumps from one node to another node. That's why this is known as a saltatory movement or leaping movement. Saltatory or leaping movement. Myelinated neuron. In non-myelinated neuron, all voltage gate channels and leakage channels are present throughout the length of axon. So, continuous conduction of information. So, in myelinated neuron, information jumps from one node to another node. That's why information travel 50 to 100 times faster in myelinated neuron when compared to non-myelinated neuron. Myelinated neurons are present in the spinal cord, cranial nerves. Non-myelinated neuron present in autonomous nervous system and visceral nervous system. If the axon is covered by myelin sheath, known as myelinated neuron. If the axon is not covered by myelin sheath, non-myelinated neurons. Myelinated neurons present in spinal cord and cranial nerves. Non-myelinated neurons present in autonomous nervous system and visceral nervous system. So types of neurons. Types of neuron based on presence or absence of myelin sheath. In central nervous system, oligodendrocyte secrete the neural lemma myelin sheath. In peripheral nervous system, Schwann cells secrete the myelin sheath. So myelinated neuron transfer the information 50 to 100 times faster than non-myelinated neurons. Now we discuss conduction and generation of nerve impulse. Generation and conduction of nerve impulse. What is nerve impulse? Momentary change of electrical potential is nerve impulse. Truly, so according to our textbook, that is the definition. Momentary change of electrical potential is known as action potential. Conduction of action potential from one end to another end of the axon is known as nerve impulse. For example, it is a axon. So in a resting condition, resting membrane potential, the electrical potential at rest is known as resting membrane potential. Inner surface of axon is electrically negative. Outer surface of axon electrically positive. So that is known as polarized axon. Polarized axon means at rest, it is not yet receive any stimulus. Neurons are electrically excited. Before excitation, inner surface is electrically negative, outer surface is electrically positive. Inner surface of neuron is minus 70 millivolts, outer surface is plus 70 millivolts. So the electrical potential of axon at rest is known as resting membrane potential. Generally minus 40 to minus 90, most of the time inner surface is minus 70 millivolts. Before we discuss the conduction of nerve impulse, it is better to discuss various channels present in the axolemma. It is the axolemma. Plasma membrane of the axon is known as axolemma. For our convenience, I drew axolemma like this. Axolemma contain leakage channels, voltage gate channels. Leakage channels are potassium leakage channel, sodium leakage channels. At rest, potassium leakage channels are more when compared to sodium leakage channels. Axolemma also contain sodium voltage channel, potassium voltage channel. So sodium voltage channel contain two gates, activated gate, inactivated gate. Potassium voltage channel contain only one gate, that is activated gate of potassium. The exoplasm, the concentration of potassium in exoplasm is 30 times more than the concentration of potassium in the extracellular fluid. The concentration of sodium in extracellular fluid 10 times more than the concentration of sodium in exoplasm. In the exoplasm, negatively charged proteins are present. So these proteins are, so for these proteins, axolemma is impermeable. These proteins neither comes out nor the proteins enter into the exoplasm through axolemma. So through leakage channels and voltage gate channels, the ions always move from high concentration to low concentration. You already know potassium is 30 times more in exoplasm. Through leakage channel, potassium always goes out. Through sodium channel, sodium always enter into the exoplasm. So from high concentration to low concentration. Similarly, voltage gate channels also, if the gates are open, sodium always enter into exoplasm. If potassium gate is open, potassium always goes out. Axolemma also contain sodium potassium pump. The sodium potassium pump transfer the ions against the concentration gradient. Transfer the ions against the concentration gradient. The sodium potassium pump send 3 sodium to extracellular fluid and 2 potassium into the exoplasm. And sodium potassium pump maintain minus 70 millivolts during resting condition. Once again, exoplasm, the concentration of potassium 30 times more in exoplasm when compared to extracellular fluid. Extracellular fluid means the fluid present outside the axon. The concentration of sodium 10 times more in the extracellular fluid when compared to exoplasm. Axolemma contain leakage channels and voltage gated channels. Leakage channel, sodium leakage channel, potassium leakage channel and voltage gated channel. Through potassium leakage channel, potassium always goes outside. Through sodium leakage channel, sodium always enter into exoplasm. Through voltage gate channels also, the ions move from high concentration to low concentration. Through sodium voltage channel, sodium always enter into exoplasm. Through potassium leakage, through potassium voltage channel, potassium always goes out. So what happen during resting phase? Potassium leakage channels are more positive charge goes out. So that's why inner surface negative charge decreases. To avoid this, the axolemma contains sodium potassium pump. The sodium potassium pump send 3 sodium to exterior and 2 potassium into exoplasm. So the movement of ions in sodium potassium pump is against the concentration gradient. So sodium potassium pump maintain the inner surface. Electrical negativity of axolemma is maintained by sodium and potassium pump. Okay, now we discuss. So you already know in resting membrane, inner surface is minus 70, outer surface is plus 70. That is known as polarized axon. Whenever it receives stimulus, at the time sodium voltage gates open, abundant amount of sodium from extracellular fluid enter into exoplasm. Inner surface is electrically positive, outer surface is electrically negative. So for few milliseconds only. So it is known as action potential. Actually inner surface electrically negative, but here 1 or 2 milliseconds inner surface is electrically positive. What is action potential? Momentary change of electrical potential for few milliseconds is known as action potential. Conduction of action potential from one end to another end is known as nerve impulse. So whenever it receives stimulus, sodium voltage gate channel open, sodium from exterior enter into the exoplasm. As a result, inner surface is electrically positive. Along with sodium, information or message also enter into axon. So now the information or message present in depolarized part. So the electrical potential of A differ from B. So the current flows from A to B. The current flows from A to B inside the exoplasm. The current flows from B to A outside the exoplasm. So the positive charge enter into B. As it create positive charge in the B. As a result, B part is electrically positive, means depolarized. B is depolarized. Due to movement of current from B to A outside, what happened? A part outside of the A, so is electrically positive, inside of the A electrically negative, that is repolarized. Again its polarity is restored. So in this manner, depolarization is conducted from A to B. So complete circuit of current. So from A, current flows from A to B inside, from B to A, current flowed outside. As a result, B part is electrically positive, inner surface is electrically positive, so outer surface is electrically negative. So B part is depolarized. Along with positive charge from A to B, information or message also travel from A to B. The same process is repeated. Now from B to C, current flows from B to C inside the axon, current flows from C to A outside the axon. As a result, C part is depolarized. Conduction of depolarization or conduction of action potential from one end to another end of the axon is known as nerve impulse. So for few milliseconds only, inner surface is electrically positive. So later what happened? The potassium channels open. So abundant amount of potassium goes out. As a result, for few milliseconds only, A part is electrically positive. So now the message travel from A to B. Immediately potassium channels open. Through potassium voltage channel, abundant amount of potassium goes out. Inner surface is electrically negative. So this is about generation and conduction of nerve impulse. So nerve impulse means a transmission of information within the axon. Once again, in a polarized axon, polarized means unexcited axon, inner surface is electrically negative, outer surface is electrically positive. Inner surface is minus 70 millivolts, outer surface is plus 70 millivolts. The electrical potential at rest is known as resting membrane potential. Resting membrane potential. Axo-lemma contain potassium leakage channels, sodium leakage channels, sodium and potassium voltage gated channels. Potassium leakage channels. At rest, potassium leakage channels are more when compared to sodium leakage channels. Concentration of potassium 30 times more in axoplasm when compared to concentration of sodium. So concentration of potassium 30 times more in axoplasm when compared to extracellular fluid. Concentration of sodium is 10 times more in extracellular fluid when compared to axoplasm. So ions move from high concentration to low concentration. So through potassium leakage channel, potassium goes out. Through sodium leakage channel, sodium enter into axoplasm. In addition to leakage channels, voltage gate channels also present in the axo-lemma. Sodium voltage gate channel and potassium voltage gate channel. Sodium voltage gate channel contain two gates, activated gate and inactivated gate. For example, in a flat, two gates. Grill is we may consider activated gate, door as the inactivated gate. If we open these two doors only, any person enter or any person goes out of the flat. In the same manner, if two gates are open, then only sodium ions enter into axoplasm. Potassium voltage channel contain only one gate, activated gate of potassium. So negative charge in the axoplasm is protein. So axo-lemma is impermeable to proteins. So at rest, potassium leakage channels are more, means more quantity of potassium goes out when compared to entry of sodium into axoplasm. As a result, positive charge may decrease. So positive charge decreases means more positive, more negative. So positive charge, to maintain minus 70 millivolts, so potassium leakage channels are more. So more positive ions goes out, more negative, inner more negative. To avoid this, sodium potassium pump present in the axo-lemma, it acts against the concentration gradient. It sends 2 potassium to exoplasm, even though concentration of potassium more in the exoplasm, and send 3 sodium to exterior. Sodium potassium pump. Okay. Axon is in polarized state. Whenever it receives the stimulus, what happens? Potassium leakage channels are less, sodium leakage channels are more. Sodium voltage gate channel open, sodium enter into exoplasm. Along with sodium, information enter. Inner surface of A is electrically positive, outer surface of A is electrically negative. After receiving the stimulus, it is depolarized, or it is also known as action potential. What is action potential? Momentary change of electrical potential. Inner surface is electrically negative, here inner surface is electrically positive. So after 1 or 2 milliseconds, inner surface again electrically negative only. So inner surface is electrically positive for only 1 or 2 seconds. So that is known as a depolarization. Momentary change of electrical potential is known as depolarization or action potential. Conduction of action potential from one end to another end of the axon is known as nerve impulse. Here in A part electrically positive inner side, in the next diagram B part is electrically positive, in the next diagram C part, D part, in this manner. So depolarization or action potential conducted from one end to another end is known as nerve impulse. Along with depolarization, information or message transmit from one end to another end of the axon. So whenever it receives stimulus, sodium voltage channels open, abundant amount of sodium enters. So due to entry of sodium, negative charge decreases. So minus 70 become minus 50, minus 40, 0, plus 10, plus 45. Inner surface is plus 45, outer surface is minus 45. In depolarized phase, inner surface is plus 45, outer surface is minus 45 millivolts. So from A, positive charge moves from A to B inside the exoplasm, and positive charge moves from B to A outside the exoplasm. A complete circuit, a complete electrical circuit is completed. So due to movement of positive charge from A to B, inner surface B is electrically positive. So the axon is temporarily, for a short period, is excited. Whenever the axon is excited, inner surface is electrically potential. Now the positive charge moves from A to B, and at the same time potassium voltage channel present in A opens. So potassium goes out. Due to movement of potassium ions, inner surface is electrically negative, outer surface is electrically positive. So in this manner, depolarization is conducted from one end to another end. It is known as generation and conduction of nerve impulse.